Good morning, students. Welcome back to science class on the chapter sound. In the previous class, we discussed the production of sound, propagation of sound. Okay, and the sound needs a medium to travel. So, in this today's class, we will discuss sound waves are why we call the sound waves are longitudinal waves. Okay. Yes, already you know, for example, how sound propagates. Okay, so here, sound, for example, when you produce a sound, then atoms are present, right? So those atoms they will gain energy, then they will collide with the neighboring atoms. Okay, after collision, they will come back to their original position. So the one the gained the energy gained that atom, so that atom is collide with the neighboring atom. So this process continuously takes place. Okay, up to listener. So now, see, in waves there are two types. In waves, two types. One longitudinal waves, another one is transverse waves. In a transverse waves, particles vibrate. If particles they vibrate like this, up and down. If the particles vibrate like what, up and down. Okay, so then that is example for transverse waves. If the particles open or vibrate up and down, okay, then we call that is transverse waves. Then in longitudinal waves, particles they will vibrate front and back, front and back. If the particles they vibrate like this, front back, okay, then that is we call longitudinal waves. Okay, see here, here sound waves are longitudinal waves. Why? Because when you produce a sound, the production of the direction of the sound and the vibration of the particles. For example, if you produce a sound in this direction, then particle also they will vibrate in this direction. Okay, see here, when you when you produce a sound, okay, the atoms present here, they will collide with the neighboring atom in this direction. Here, the production of the direction, then the vibration of the direction of the vibrations of the particles, both are in same direction. Okay, so here first they will collide, then they will come back. So this is also here white particles will vibrate first front, then they will come back. Okay, so here particles they vibrate front back. Okay, so that's why we call sound waves are longitudinal waves. So clear why we call sound waves are longitudinal waves? Why? Because here particles they will vibrate. Okay, front and they will move first to front, then they will come back to the original position. So here in sound, the direction of the particles here front and back. Okay, if you take one slinky, already you know you have played with that slinky. Okay, see here this kind. Okay, just observe here, you know, slinky it is just like a spring. For example, when you give push like this, so here just observe here all the springs are compressed here that means the distance between the strings, that is it is far. Okay, it is huge. Then here so compressed, here compressed, and here compressed. Okay, so when you push, so you can see this kind of motion. So here the spring they will vibrate in this first in this direction front, then they will come back. Okay, so this is the example for how sound waves travels. So clear? So in the sound, why we call sound waves longitudinal waves? In the sound, so when you produce a sound, at that time sound it will move. How? So when you produce a sound, the particles they will vibrate front and back. First they will gain energy, they will move forward. They move forward and they will collide with the neighboring atoms. Okay. So after collision, the atoms they will come back. Okay. So that's why we call sound waves are longitudinal waves. Okay. So next move to characteristics of a sound wave. what are the characteristics of a sound wave. Okay, see here. So we can represent that sound. Okay, so graphically, so we can represent sound graphically. See here like this. See here, you know. See here, when you produce a sound, so this in the previous class we have seen, right? When you produce a sound, so from that production to the listener, okay, what we can hear this kind of compressions and rarefactions, okay. So when you produce a sound here, what will happen? The atoms will gain energy, they collide with the neighboring atoms. So we call this portion as compressions, okay. After collision, they will come back, right? The atoms will come back to the original position. So we will call that as rarefactions, okay. So while traveling sound, these kind of compressions and rarefactions takes place, okay. So graphically, we can represent this compression like this, okay. So we can represent it graphically. Which one? This is, see here, this this is a wave, okay. This is a wave, we call this crust trough, crust trough, okay. So here this length is equal to this one, okay. The height, length and width, everything is this crust, which is equal to this one, okay. So now we'll represent this crust, this compressions, okay, this one, and we'll represent this rarefaction in rarefactions in a trough, okay. So compression, compression, rarefaction, okay. That collision and collision, okay. So when we collide that compression, we can represent this one, that rarefaction, this one, okay. So graphically we can show the sound waves like this, okay. Okay, see here. First characteristics. First we'll study which one? Wavelength. Okay. First we'll study what is wavelength. Okay. See here, the distance between two successive crusts or trough. Okay. The distance between two successive crusts or troughs is called wavelength. Now these two are crusts, right? The distance between these two crusts, not crusts and trough. the distance between two successive means continuous. See here we can't take distance from this crust to this crust, not that one. Okay, the distance between successive crusts, or we can take the distance between successive troughs. Okay, so this distance is called wavelength. Here, this distance is called wavelength, and we represent that wavelength using this symbol. And name of this symbol is lambda. Okay, so we use this lambda to represent wavelength. Okay, so now this distance, the distance between two successive crusts or troughs, is called wavelength. Or we can, in other words, we can say the successive distance between two compressions, or we can say the distance between two successive rarefactions is called wavelength. Okay, so this is the first characteristics of sound wave. So what is that? That wavelength. So what is wavelength? Wavelength means the distance between two successive crusts or trough. Okay. Suppose all the waves, all the sound waves, you can hear different sounds, right? The sound from guitar, the sound from speaker, and the sound from sitar, veena, and band, whatever it is. Then we can hear different kind of sounds. Okay, so wavelength of all sounds are not equal. Maybe some sounds they have wavelength like this, very close. Okay, so here we can say that the distance between these two successive are less, but if you take this wave here, the distance is very high. Okay, then what is the SI unit of wavelength? Wavelength means what? The distance between two successive clusters. So here we are measuring distance only, right? So that's why the SI unit of wavelength is meter. The SI unit of wavelength is meter. Clear? The SI unit of wavelength is meter. Next, actually, see, usually these we can't measure. Okay, these distances in our eyes. Okay, because the distance between the eyes is very small. Okay, so that's why most of the times to measure that wavelength we use nanometer. Okay, nanometer means 10, nano means 10 raised to the power minus 9. Okay, so 1 nano equal to 10 raised to the power minus 9. Okay, so this distance is very huge, small, so that's why we use this nanometer. But the SI unit of wavelength is, that is meter only. Okay, yes sir. So all the sounds means no need to what, all the sounds they don't have equal wavelength. Okay, maybe some sounds they have the distance is very huge and distance is very less. Yes, so next move to frequency. So next move to frequency. See, frequency means, when you produce a sound, what will happen? These atoms they will vibrate. Okay, so frequency means in a given time, how many times it vibrates. In a given time, how many times it vibrates. So we call that is frequency. Okay, see here, for example, now take here from here to here. We call this is one wave. One wave means, see, we call this is one complete wave or one complete cycle. Okay, one crust and one trough. Okay, so here this single wave, what it represents? It represents the collision and compression and rarefaction. Okay, see, when you produce sound, what will happen? Both will collide. Okay, this collision we can represent this one. We call this compression. So after collision, what will happen? So this atom it will come back, and this atom it will collide with the neighboring atom. Okay, clear? So we call this as reflection. We will represent this reflection in troughs. So clear? So compression, rarefaction. Okay. Okay, so frequency means the number of waves passing through a point of the medium in 1 second is called the frequency of the wave. Or in simple words, we can say that in a given time, how many waves are passing. Okay, so wave means one crest and one trough. In a given time, how many waves? How many these kind of waves are passing given time? So that is called frequency. Or in other words, so the frequency means the number of times the atoms they vibrate in a given time. So even we call also when we can say that is frequency. Okay, so frequency means in a given time how many times that particles vibrates. Okay, how many times? If it vibrates only one, we can say that's one frequency. If vibrates 100 times, then we can say that it has frequency that is 100. See here, what is frequency? Frequency means the number of times the particles vibrates. Okay. Next, what do you mean by? See, in other words, we can define the number of waves passes through in a given time. Waves means one crest and one trough. Okay, so this is one wave. So how many these kind of waves? These kind of waves passes through in a given time. So clear? So that is called frequency. Okay. To represent the frequency, we use one symbol. Okay. That is it is just like a V. Okay. See, we pronounce it mu. Okay. How to pronounce that is it's not V, it's mu. Okay. And the essence of a frequency is hertz. Okay, the essence of frequency is hertz, that is capital H and small z. Okay, see here, for example, in 1 second, say we have one wave. Okay, so in 1 second, so one crust and one trough passes. Just imagine in 1 second, one crust and one trough. Okay, then we can say that is 1 hertz. Okay, I think you have seen right this at 20 hertz in your mobile and somewhere in speakers 20 hertz, 50 hertz, okay, 100 hertz, like that. Okay, so then what is the meaning of a 1 hertz? 1 hertz means one wave in 1 second. One wave means one complete wave. Okay, that wave which includes crust and trough. So clear? So what is the meaning of frequency? Frequency means one wave. One wave means one crust and trough. Okay. Suppose what is the meaning if it is a 5 hertz? 5 hertz means in 1 second 5 cycles passes. Okay. In 1 second 5 cycles passes. 5 cycle means 1 cycle which includes crust, trough. Second one crust, trough. Okay. Then what is the meaning of 20 hertz? 20 hertz means 20 cycles in 1 second. Then what is the meaning of 50 hertz? 50 hertz means 50 cycles in 1 second. Okay. Then what is the meaning here? See here. Here 1 hertz. 1 hertz means see what is the sound? What will happen? See atom. It will collide with the neighboring atom. Collision. Then it will come back, right? So we will call that as 1 hertz. Suppose suppose if see here, what is 5 hertz? What is the meaning here? So 5 hertz means see here, this atom will collide. Okay, it will collide with this atom 5 times. How many times? 5 times. Okay, then we can say that frequency is 5 hertz. If it collides 50 times in 1 second, 50 times means compressions, rarefactions. Compressions, rarefactions. Okay, if it vibrates 50 times, then we can say that its frequency is 50 hertz. Okay, so this is about frequency. So clear? Yes. Next, move to amplitude. And see here, what is the definition of frequency? Frequency means the number of times particles vibrates in a given time. Okay, so to calculate the frequency, we have formula, that is the frequency V is equals to 1 by T. Okay, V is equals to 1 by T. Clear? So frequency 1 is equals to 1 by T. Yes, sir. So here, frequency. Okay, to calculate frequency, we use formula, that is frequency equal to 1 by T. Why it is 1 by T? Frequency means what? The how many waves are passes through in a given time. Okay, the number of waves passes through in a given time. So that is the frequency. So that's why to calculate frequency, we use frequency equal to 1 by T. So here T means time period, how many times it vibrates. For example, say. What say one wave, okay, say some waves are passes in say in 5 seconds, okay, one wave, so it is passing, I don't know how many waves are passing, but that means 5 seconds. So I will ask you to calculate what is frequency, so then you can calculate easily. So that is 1 by 5. Okay, so next we will discuss amplitude. Okay, so amplitude means, see, amplitude means the maximum displacement of the particle of the medium from its mean position is called the amplitude. Okay, so what is amplitude? The maximum displacement. The maximum displacement. Okay, the maximum displacement of the particle of the medium from its mean position. From its mean position is called the amplitude. You know, here these are atoms. So when you produce a sound here, what will happen? So this atom which receives energy and it will collides with the neighboring atoms, right? Okay, neighboring atoms. So here this collision from this here, this is the rest for the mean position of the particle. When you produce a sound, what will happen? So it collides with the neighboring atom. So it covers some distance, right? Okay, it displaces from its original position. Okay, see here, this distance from here to here, this distance is called amplitude. Okay, this distance, suppose say it will cover more distance, so then we can say that it has more amplitude. Okay, so in graphically we can say that here this crust represents, see, this crust represents the what, the compression, the distance from this mean position to this peak, this distance is called amplitude. Okay, this distance from this, here we call this is zero position or mean position. Okay, the distance from this mean position to this crust, the peak, this distance is called amplitude. Okay, now see here, maybe some waves they have different amplitudes. For example, see here, take these two waves, okay, and one more. Just observe here. Here the distance from this crust to mean position, here distance is less, but here distance is more. So now we can say that this sound it has more amplitude. This sound it has more amplitude, and this sound it has less amplitude. Okay. Now, see here, clear it what is amplitude? See here, that maximum distance when you produce a sound, if it covers less distance, then we can say that it has less amplitude. If it covers more distance, then we can say that it has more amplitude. So clear? Amplitude means what? The maximum displacement. So amplitude. For example, so here we have two sounds. Okay, here we can say that this is the sound. Loudness of this sound is less, and soundness of this wave is more here. So clear? So this is about amplitude. Okay. So here in waves, okay, this distance, suppose here, say here to here, say what 6 centimeter. Then what about here? So here to here also 6 centimeter. So clear? So these three are the characteristics of a sound wave. Okay. So first one we have studied wavelength. So what is the wavelength? Wavelength means the distance between two successive crests or troughs. Okay, two successive crests or troughs, or we can take this also. Or in other words, we can define wavelength means the distance between two successive compressions or two successive rarefactions is called wavelength. Okay, and we use lambda to represent wavelength. Then this extent of wavelength is that is meter. Okay. Next, we'll study frequency. Frequency means what? The number of times the particle vibrates in a given time. How many times the particle vibrates in it, that is called frequency. Okay. If it vibrates more times in 1 second, then we can say that it has more frequency. If it vibrates less time, then we can say that it has less frequency. Okay. In other words, we can define the number of waves passes through in a given time. Okay. And to can we represent that symbol mu. Okay. We use that mu symbol to represent frequency, and we have formula to calculate frequency, that is mu equal to 1 by t. Okay, so here t means what? Time period. Next, amplitude. Amplitude means what? The maximum displacement of the particle of the medium from its mean position. Is called amplitude. Okay, so if the distance from this peak point to this mean position, if the distance is more, then we can say that it has more amplitude. If the distance is less, then we can say that its amplitude is less. Okay, the soft sound, they have what? Less amplitude, and louder sound, they have high amplitude. Okay. Yes, so I think time is over. So I will stop here. So tomorrow we'll continue the class. In tomorrow's class, we'll discuss, for example, you are just imagine you are listening to music. Okay, just imagine you are listening one song. In one song, you can sometimes hear what one is bass sound. Okay, bass sound, then guitar sound, then violin sound, then one singer. Okay, one singer and a flute, etc. Okay, sitar, veena, and saxophone. You can hear in one song. You can hear many sounds of instruments. Okay, but you can recognize easily. You can identify the different kinds of sound. Okay, you are see the volume is same for all the sounds, but you can easily identify, right? Okay, why these sounds? Why you can hear the different sounds? Okay, everything we'll discuss in the next class. Okay, see, while hearing, no need to equal the amplitude, wavelength, and frequency. Okay, maybe if you hear all the sounds of these instruments at a time, maybe maybe the sound of bass, volume, wavelength of bass is different. And if you take guitar sound, okay, maybe its amplitude is less. If you take violin, its frequencies may be high. We don't know. Okay, these three. Then we have more characteristics. That is, one is pitch and quality or timbre of the sound. Then tone. Everything we'll discuss in the next class. Okay. Thank you.